light on, right? Because light kind of cancels out the dark. But light is able to cancel itself out. So it's acting like a wave, okay? Now remember, we left at this section right here, and we said that Isaac Newton, for an example, when I had my laser and shined it on the whiteboard, it bounced off of the whiteboard and it reflected to the blue part, right? And vice versa. Because it was acting, quote unquote, like a particle. Now, light over here is acting like a wave property with interference, okay? Well, it wasn't until this super smart guy, Albert Einstein, comes along and he, again, kind of steals somebody else's idea. Ideas are able to be stolen anytime until you are able to do an experiment and prove it. And so he comes along, Albert Einstein, with his smartness, and he does a pretty cool lab experiment and shows us some pretty cool stuff. It says here, under the right conditions, light can be used to push electrons, or free them from the surface of a solid object. What? Let's keep going with our notes, and I got a quick 3-minute video. This process is called the photoelectric effect. The photoelectric effect was first talked about with Hertz. Sounds familiar, right? Frequency, Hertz, back in 1887. But it wasn't until later on when we had this guy Einstein who came up with this experiment. It says here that the energy of the electrons depends on the color or the frequency. Didn't that video at the end, the guy in the yellow shirt, he said, whoa, the only thing different between red and green, or the difference between color, is their wavelengths or frequencies, right? Which has to do with the color's energy, right? Green is different from red, okay? Whoever wants to take this class on or this argument, how do you know it was green? You were just brainwashed as a baby and you were told that green is green. No, I wasn't brainwashed. I know that a certain frequency or a wavelength always will be a green color, no matter what. Definitely we're not brainwashed, okay? And nobody just came up with this color and said, oh, that color is going to be pink, that color is going to be red, that color is going to be green. No, we know that scientifically, we know that the frequency or the wavelength is going to determine that color. It says here that of light, and not on the intensity, okay? Meaning how strong the light is. That has nothing to do with the brightness. So which color has more energy? For an example, the question here is, which color has more energy? Would it be green or would it be red? Green or red? We already talked about this. We should be able to know the answer to this. Between these two colors, which one has more energy? Well, hopefully deep down in your heart, your gut, you're saying green. Green definitely has more energy. Well, I will say, for an example, I have my laser over here, right? And, the lasers, when you read the instructions, who does that, right? But when you read the instructions on the box of the laser, it says, be careful, even this red one. I just said right here, who has more energy, green or red? Green, definitely. That means that this red laser, even though I read it, they just want to be super cautious and cover themselves, right? Like, I'm not supposed to come over here to Josiah and he's like, whoa, you see the little dots now, huh? And hold up, don't move. Just shoot the red laser he's closing his eyes, into his eyes. Deep down inside, I know that I did not hurt his eyes. Yes, he probably sees the little dots right now. But if Miss Munson was about to come over here and pull out a green, or wait a minute, a blue laser, I would physically hurt him. The amount of energy, and I don't care brightness, it doesn't have to be very bright. But if I was, and this is not, it's a green and blue pen. But if I was to go, because that would be wrong, right? I would never, ever physically hurt a student. Emotionally, that's different, right? But physically, I would not go to a green laser and shoot it, or even a blue laser. What would be stronger than a blue laser? RGB, indigo or violet, right? Right? Those, you can't do that. The amount, the intensity of that would be crazy, right? You're definitely going to hurt yourself. Can you imagine now going back to those people who are going to be laser welders? They better still wear those those hoods to protect their eyes from that type of intensity of, well, not necessarily intensity, but energy from the light. It says here that Einstein explained this by the process. What happens here is that light is made up of what he says, photons. He says light is made up of these little photons. Actually, we're going to get into photons a little bit more next unit, okay? And he says that the threshold, again, this may not make sense until we watch the video, of the frequency is different for each different type of material. Am I talking about a whiteboard? Am I talking about a piece of metal material? Okay, so I'm going to pause for a moment.